Good morning or good afternoon, depending on where you are. I'm Chris Spinagle from the Warning Decision Terrain Division. I'd like to welcome you to today's Storm of the Month presentation. Today's presentation comes to you from the National Weather Service office in Columbia, South Carolina. Our presenters are Matt Gropp and Pierce Larkin, who will be presenting Georgia and South Carolina surprise QLCS tornadoes of January 4th, 2023. With all that being said, Matt, the floor is yours, so go ahead and take it away.
All right. Well, thanks for tuning in, everybody. Here to talk about one of the busier days in my weather service career so far. I think the same thing could be said for Pierce. I'm going to lead it off here and give a little bit of a meso analysis, and then we'll get into some of the radar signatures for these events from Pierce. So how the day started was we had Pierce there working some serious radar ops in the morning with numerous tornadoes and severe warnings and all sorts of things going on, and it ended with actual storm surveys in the afternoon because this event moved through so quickly. We had all of our stuff done in the morning, and then we were out doing storm surveys in the afternoon because a few of the tornadoes were pretty close to the office. So just for some context here, this is our forecast area across eastern Georgia. That little sliver there includes the Augusta area, and then we go up through the Midlands of South Carolina and then right up bordering the Charlotte metro near Lancaster County there. So the event outlook and what we kind of came into on the day shift that day, SPC had outlooked in a marginal risk. Slight risk for wind just clipped our kind of extreme western area in those counties in Georgia. So we had a conditional low end threat, and kind of the thinking at the office was pretty much in line with what SPC was thinking, is that there really wasn't going to be enough instability for a major severe outbreak in our area. And especially with the timing, we thought it was going to be more of an afternoon event. So we didn't think the instability was going to be there in the afternoon, let alone in the morning when the actual line came through. Big things and issues that we were thinking about were like isotropically forced showers. We thought maybe some deep convection to our south would cut off moisture coming to the north, things like that. So then what was interesting about this was there was some signals that we could have a bigger event, and the Colorado State machine learning probabilities did highlight this actually from 4 days in. If you start on the top left there and then kind of go around clockwise, it goes days 4, day 3, day 2, and then day 1. You can see it highlighted kind of the Midlands of South Carolina with that enhanced tornado threat all 4 days. But I should note the caveat here that the Colorado State machine learning probs do get a little bit false alarming with these types of events where you have a lot of low-level shear. They tend to really pretty much highlight every one of these events as a potential tornado outbreak. And a big area of the risk it's highlighting there did end up busting, but it did get the central Midlands of South Carolina pretty well. So what ended up happening is we ended up being a little bit understaffed. We could talk a little bit more about that later. And we had 11 warnings, damaging macro burst that had up to 90-mile-an-hour winds over a pretty wide swath down there in Burke County in eastern Georgia. And we had 5 tornadoes that occurred all within a 30-minute period and pretty close to the office. Our office right there is kind of right by the warning 3, and that was the one that actually included our office. And yeah, it got a little busy when we had 5 tornadoes occur in a 30-minute period. So why were we a little bit caught off guard by this event? Well, it was mainly because guidance just really struggled in general with this event. The HRF had pretty much no instability. Even with more favorable diurnal timing, when it had the line coming through in the afternoon, it still didn't have a lot of instability. Here we show the stamps for the HRF members at 14Z. So this is when we had all the tornado and main severe weather. And you can see only a couple of the members have even any surface-based instability coming into our CWA. Really, none of them had anything into the Midlands of South Carolina. Eastern Georgia was about the only area that saw it. And this is part of the reason that we thought the threat would diminish as it headed east, but it did not. Timing was also a big issue. Only 2 members had the timing kind of right, about 14, 15Z. Coming through the Midlands of South Carolina, you can see there it was the 2 in the top row, the ARW and the NSSL had the timing pretty good, bringing that bode segment through about 15Z. And then this is the calibrated STP guidance. Obviously, we didn't have any significant tornadoes, but gives you a sense of where guidance was highlighting for the most favorable environment. And then those UH swaths there were generally all to our west, and then the best environment is to our southwest. You can see all those warnings and reports that we had across central South Carolina there that were just, on the edge of that even decently favorable environment. So overall, the synoptic summary, we had a big difluent trough aloft with a pretty strong jet streak to our northwest. Down to 500 millibars, kind of a stacked low, but we had pretty good height falls aloft, which ended up contributing to some better instability than we thought. And pretty good void advection. So the forcing from a synoptic standpoint was pretty good. Down at 850, we had really good moisture advection. See 850 dew points there, kind of surging, 14C or so. And then over at the surface, this is the WPC, overlaid fronts and stuff here. We had that low tracking up through northern Kentucky, the squall line associated with it, pushing into central Georgia, and that's at 12Z. So this is like right when we're coming in for our shift, and this is kind of what we're looking at. So the environment at 13Z, so basically just as stuff was getting close to our warning area, we see kind of a widespread area of 500 plus mixed layer capes. So this is definitely higher than what we were seeing overall in the HRF members. We had extremely strong effective bulk shear, 50 plus knots for most of the area. Then we move down to surface to 3 kilometer shear, which is going to be pretty important from a QLCS tornado standpoint. Very strong in 30 to 40 knots across the whole area, and generally oriented right out of the southwest. And then while we weren't really worrying about supercells, the 0 to 500 SRH here can give you a sense, at least a little bit, of how much turning and shear we had in the low levels, and again, why we may have had some of those QLCS type tornadoes, and we have that band of 100 plus 0 to 500 SRH, just give a sense of how much veering and speed shear there was in the lowest levels. And then again, from a QLCS tornadoes perspective, we didn't have a ton of cape overall, but we did have enough low-level cape. So we had that kind of tongue of 50 to 100 0 to 3 kilometer mixed layer cape that spread into eastern Georgia and the Midlands of South Carolina. And overall, this reason this environment kind of set up this way was we just didn't really have any shower activity ahead of the line that we were kind of expecting to keep us a little bit more stable. And that was the main reason why we ended up having this instability. So we just do a point sounding here to give you a little perspective from a vertical sense. We were substantially more unstable than we were forecast. We didn't have that prefrontal convection. You can kind of see the influence of some of those height falls aloft at 500 millibars where we had some decent lapse rates. We're saturated at low levels. And then again, when we're talking about QLCS tornadoes here, we had that quite good 0 to 3 kilometer cape across the area. And you can see from the photograph behind it, very strong shear out of the southwest. You're talking 40, 50 knots at 3 kilometers there over Columbia at this time. So then right as the event begins, so this is an hour later, I just wanted to show kind of the QLCS tour layout from the SPC meso page where it has the 0 to 3 kilometer shear and the 0 to 3 kilometer mixed layer cape. You can see kind of right from that tongue of 50 to 100 ml cape right over eastern Georgia into the Midlands of South Carolina, where we actually had a bullseye of over 100 mixed layer cape. That's going to be where we had those severe reports in the tornadoes, especially in the Midlands of South Carolina. And then we'll talk about this probably towards the end a little bit, but when you have 40 plus knots of 0 to 3 kilometer shear, you have a pretty wide range of potential line orientations to get those segments where you're going to see the quick mesovortices and spin-ups. When you have 40 knots, pretty much any little kink in the line is potentially going to produce a mesovortex and maybe a tornado. So I'm going to hand it off to Pierce here. He's going to talk through the radar examination because he was the one on the desk that day. He's going to critique himself a little bit.
Yes, I am going to critique myself. So like Matt said, my name is Pierce Larkin. I was on the radar desk that day. And so any critique that I offer of the radar operators, no, it's a critique of me, and I'm not just, lobbing shots at random people in my office. This is directly at me. When we were designing this presentation for our severe weather workshop earlier this year, we thought this was a perfect way to look at this event and look at future QLCS tornado events from an anticipatory perspective as opposed to reactionary, because we were very reactionary on this day. And we were caught off guard. Even when we got into the office and it moved into our forecast area, we're still a little caught off guard. And so looking back at this through the lens of the 3 ingredients method, we learned that this and future events can be anticipated with a lot of skill. So I'll review the 3 ingredients method, which is system cold pull and ambient low-level shear, nearly balanced or slightly shear dominant. It's just the updraft, downdraft convergence zone. I'll show you an example of that in a second. You want 3 kilometer line normal bulk shear greater than 30 knots, like Matt was just saying. and then rear inflow jet or enhanced outflow causing surges or bows within the QLCS. So as I step through this, I'll work through the initial perspective of someone on the meso desk helping the radar operator kind of synthesize environmental information and current radar data to anticipate down the line, and then I'll work into the radar desk and I'll talk about some of the things we were seeing that day that we should have anticipated ahead of time. So we'll start with the radar at JGX in Central Georgia at 13Z. You know, Matt and I, we sat down that day and we looked at Central Georgia, seeing this line of thunderstorms, and we said, what's going on in Georgia? And so we got settled in, we looked at this, and we saw this velocity image. And so we're going to outline where the updraft, downdraft convergence zone is here in white. And then if you overlay that with the reflectivity, you can see where it is cold pull dominant or shear dominant. And we can see we've got this segment north of JGX that is balanced or slightly shear dominant and is about to ingest some other storms. So let's check off number one. We have that balanced cold pull, and we've got that in the favorable location, the updraft, downdraft convergence zone. So like Matt was saying, we have plenty of 3-kilometer shear, and we've got shear vectors that are nearly line normal with that line segment in Central Georgia. Let's check that off. And then, as you note, north of Macon there, between the two vectors that I've got there, we've got a little bit of a reflectivity drop indicating a potential rear inflow jet. So let's check that off. 3 ingredients method, every single step is noted here. And then if we look at the confidence builders and nudgers, we've got plenty of those as well. We're about to ingest these storms. If you go back and see the velocity here real quick, they have little weak mesos embedded in them. And so if we go into here, we know that this line is about to ingest some more storms, or we've got storm ingestion, front reflectivity nodes, updraft, downdraft convergence zone entry point. We've got an enhanced surge and bow. We've got a boundary ingestion, not only a little boundary ahead of it, but as we'll talk about later, we've got an outflow boundary just to the north here, north of like Washington, McCormick, up into north of Saluda there. That's going to be sinking southward, and that's going to play a big role. So let's outline as the mesoanalyst where we can anticipate severe weather over the next couple of hours. And that's right there in the CSRA of Georgia and the southern Midlands of South Carolina. And so based on that anticipation, we're going to jump ahead at 1417Z. The line segments are now organizing and entering our forecast area. So as the mesoanalyst, you know what the environment is like. And so you're helping the radar operator kind of get a sense of what to look at. So the strongest portion of the lines are now into the area. We've got 2 line segments. We've got one across the south that has that severe thunderstorm warning still in Atlanta's area, and we've got one across the north. Obviously, that one across the south is much stronger at this time, but it's still mostly convergent as it's moving into the Burke County and southern Augusta metro. But based on our 3-kilometer shear vectors, we're going to be watching both of these line segments because even though it's mostly convergent in the southern portion, you can see this northern segment has weak mesovortices starting to develop, and there's a southward moving outflow boundary that's going to start interacting with that as it gets into Edgefield County and Saluda County and approaches the Columbia metro. So now we're going to jump ahead a little bit more in time. And this is really when we're starting to look as the radar operator. Now, just note, you don't see any warnings on here. I assure you, we did have warnings out. Don't let this confuse you. I turned those off in GR so that it's easier to annotate this. But as the radar operator, you're watching an organized QLCS work through the region. Now, we're going to try to anticipate instead of react. Given the 3-kilometer shear vectors, 3-kilometer cape, we already know about which set we'd be watching. So we can see the 3-kilometer shear vectors. We've got 2 areas where it's nearly line normal. This Boeing segment with this already established good mesovortex south of Augusta there. And then we've got these fairly strong mesovortices that are already starting to develop in eastern Edgefield County and are about to interact with the slow-moving outflow boundary. So as the radar operator, now you can anticipate that the most favorable locations for tornado genesis over the next 1 to 2 hours are going to be approaching the Columbia metro area and then in Aiken County just south of the Columbia metro area. So now as the radar operator, I'm sitting there. I need to be anticipating. I was very reactionary this day, very reactionary. So we're watching the northern line segment as it approaches the Columbia metro area. And this is what I see. I have a severe thunderstorm warning out, but I don't have a tornado warning out. And the first tornado has already begun. So these weak mesovortices in western Lexington County had multiple tornado warnings drawn up for this. I should have just issued on it. But I was not anticipating the interaction that these mesovortices would have with this outflow boundary. And they had already been developed by the favorable environment, and now they're just interacting with the outflow boundary. And this adds enough low-level shear to spin up one weak tornado in western Lexington County. You can see there's a tiny TDS there. I'll zoom in there, right there. Small TDS associated with this mesovortex and tornado just southeast of Gilbert in Lexington County. And then there was another one that formed just south of the office as it interacted with the southward moving outflow boundary again. And so, you know, as the radar operator, I should have been able to anticipate that this was going to happen and get the tornado warning out early enough. And so while I reacted in this case, I anticipated there would be another tornado with this line segment as continue moving through Lexington County, and issued that tornado warning, then issued another tornado warning right after this, just to stay ahead of it since it had already produced 2 tornadoes. And one of the issues we were actually having this day, I'll get to this in a second, was that the TDSs were very difficult to distinguish close to the radar because it was so noisy. That's one of the things we learned, but I'll get to that in a second. So as the radar operator, should have been able to synthesize the environmental information with the radar information to anticipate this. But you can see that if you do use the 3 ingredients method, the nudgers and the confidence builders, and you synthesize all of that together with the current radar information, you can project ahead and anticipate tornado genesis within a QLCS like this. I'll let this loop through here real quick. Here's just an overall loop of the event as it pushed through the central Midlands, South Carolina. This star is over a very tiny tornado track that developed in Calhoun County that was indistinguishable otherwise. You can see this was a very kind of mesovortice-ish line segment that moved through. While we didn't have tornadoes anywhere further south, you can see that boundary interaction, especially in the northern portion there. The boundary interaction, that outflow boundary, and then the leftovers of that strong meso that had developed and produced a really strong macro burst. As that moved up into Aiken County and then south of the office, that actually led to multiple tornadoes being developed as well. So the final result was an impactful cool season severe weather event. We had 5 tornadoes in 30 minutes of each other, and in addition, there was an extensive macro burst in Burke County. All in all, given how difficult this was to anticipate and how we were staffed going into it, I think that warning verification turned out fairly well given the nature of the event. We can actually anticipate potential tornado genesis ahead of time in QLCS setup. So you're going to look for 3-kilometer cape greater than 40 joules per kilogram, line normal bulk shear vectors greater than 30 knots, and also look for cell mergers or boundary ingestion. Those are going to be very important to adding potential vorticity to spin up quick tornadoes. And then one of the big things that we took from this, in QLCS tornado events, use MERL within 50 nautical miles of the radar. SAILS is great for getting that extra half-degree scan within the volume scan, but you're only getting half-degree, and close to the radar, that's going to make it very difficult to distinguish what's actually going on, and if you do have a TDS. So for example, you see right here over this tornado track, you can see that this is obviously a TDS, but in the moment, it's very difficult to discern that because of how noisy it was. You can see there are multiple areas of CC minimums on the correlation coefficient over here. And so we were looking at additional scans. We were obviously looking up in the actual volume tilt, but because we were only using SAILS, we were getting old radar images because it was taking so long to actually get through that full volume tilt. And so if you use MERL, you're going to get up to 4 additional scans in the lowest levels. And within 50 nautical miles of the radar, that is so critical in being able to distinguish whether you've got a TDS or not. Know your environment, KYE. This is one thing I hammer home. I love to be a mesoanalyst in these situations because the radar operator needs to know what's going on in the environment. Even if you don't have the time to, if you're busy on a day like this, you're doing multiple things. You're not just a mesoanalyst. But even if you're busy with LSRs or anything, just given every now and then, like every 30 minutes or something, give the radar operator, this is what's going on with 3-kilometer shear vectors. This is what's going on with the mixed layer cape. This is what's going on with 3-kilometer cape. It is so important that the radar operator knows that so they can synthesize that information with what they're seeing on radar to make good warning decisions. And then segmentation of these events is very key. As a primary radar operator that day, I should have asked the backup to either take different segments, like take north, I'll take south, or have them focus on severes and I'll take tornadoes. Because I believe that I would have been able to catch that first tornado if I had actually segmented out the workload, if I had offloaded some of the workload, but I didn't, and so that's just a learning point for me just in general. And then don't beat yourself up too much. QLCS tornado warnings and QLCS tornado events are so intimidating. They're very challenging, but know that through practice of seeing the actual signals, seeing the radar things to look for, knowing your environment, you can conquer tornado warnings in QLCS events. So with that being said, any questions?
Just want to say, ironic, Pierce, that you're saying don't beat yourself up, and you were beating yourself up there. You did great.
Oh, that's true. Yeah, I was doing that, but that's it's just the life.
I was going to say, leaving it on a positive note, you got to conquer your fears and everything. So yeah, thank you both for for coming forward and talking about a surprise event that sounded pretty challenging. All right, well, I want to thank you both again, Matt and Pierce, for being interested in presenting on this case and talking about some of the challenges that you all face and having a wealth of information here for us to digest. So thank you so much for putting together this talk and rounding out our Storm of the Month series for 2023. This is our last session of the year, so thank you all for joining and being interested in these webinars, and we'll kick things back up in 2024, and you'll see some more information on what those will look like here in the future. So Matt and Pierce, thank you again, and everyone have a good rest of your 2023.